In this unit, we'll be discussing buffers, and buffers are very important to resist changes in pH so that certain reactions can run in the conditions that they need. All right, a buffer is made from weak conjugates. So what that means is when you make a buffer, you need both the HA and the A minus. Now, if we start with HA, an equilibrium would make some A minus, but not enough. So what you're doing is when you make the solution, you will add some of HA, and then you have a source of A minus that is separate. And this is most likely an ionic compound like sodium A, and these ions must be the same in order for these to truly be conjugates. And so you have these two sources and you add them both to make the buffer. You choose the buffer system based on the pH that you need, and a buffer works best in the range of pKa plus or minus 1. So what is pKa? pKa, remember P is just a mathematical function that means negative log. So pKa means negative log of the Ka for the acid. So you just look up the Ka, take the negative log of it, and you find that range. So let's say you have a Ka of 1 times 10 to the negative 5. Therefore, your pKa would equal 5. So your buffer would work in a range of pKa plus 1 to pKa minus 1. So if your pKa equaled 5, it would you could make a buffer that could work in the range of pH equal 4 to 6. And the buffer works really well when there's equal amounts of each conjugate, because each conjugate is designed to help. One's an acid and one's a base, so they can help tackle bases and acids that are added to the system. Now, if you want to know the pH of your specific buffer system, it's going to depend on the actual concentration of the conjugates. So you have some weak acid and its conjugate weak base. Depending on the proportions that you have, you can adjust the pH. So if they're equal portions, then you're working right in the range of pH equals pKa, because these would be equal. But when one is a little bit more than the other, when you have different amounts, then you can adjust your pH as needed. And you can just plug into this equation to determine pH.